morning to all of my students. So today I will give lecture number 5. So what we were doing the theorem 1.22, and in theorem 1.22 we were doing B part. What is B part? B part is this, that for every uv belongs to m0, a की power m plus u is equal to a की power m plus b if and only if u is congruent to v modulo r. So we were doing the cases here. We were on, I think, case number 2. That is, let a की power m plus u is equal to a की power m plus b, and then we were doing case number 2. That is when u lies between r minus 1 to 0 and v is greater than or equal to r. Correct? So see, when v is greater than equal to r, we can apply division algorithm. That is, by division algorithm, what we have, there exists q and u such that q and t such that v is equal to rq plus t, where q is greater than or equal to 0 and t lies between r minus 1 to 0. This we have. Correct? Now let's calculate a की power m plus b. So what we have? We have a की power m plus u equal to a की power m plus b. Correct? So a की power m plus u is equal to a की power m plus, put the value of p here, that is rq plus t. This is a की power m plus qr into a की power t. What is a की power m plus qr? This is again a की power m into a की power t. Since a की power m is equal to a की power m plus qr, so this is a की power m plus t. Now see, a की power m plus u is equal to a की power m plus t. So what does it implies? See, m plus u lies between range. Both these, according to previous case, what we have seen, that these are the distinct powers of A, and if these two powers of A are equal, it means that m plus u is equal to m plus t. It means that, it implies that u is equal to t. So we get u is equal to t here. Now you put here, that is v is equal to rq plus u. So v minus u is equal to rq. What does it imply? It implies that u is congruent to v modulo r. So in this way, we have proved that, again in this case, u congruent to v modulo r. Now case 3 is dual of this case. Dual means that if you talk about the case 3, you just replace v here and replace v by u and u by v. So when v lies between 0 to r minus 1 and u is greater than or equal to r, we can do in the same fashion. So in this way, for this dual case, that is case 3 is a dual of case 2, we can prove that u is congruent to v modulo r. Now we look for the final case, that is case number 4. What is case number 4? Case number 4, that is when u and v are both greater than or equal to r. That is u and v both are greater than or equal to r. Now again, by division algorithm, of integers, there exists q1, q2 greater than or equal to 0 and t1, t2 T1, T2, and both lies T1 also lies between r minus 1 to 0, and T2 lies between r minus 1 to 0. As we are applying division logarithm on u and r and v and r, so what we have, so by division logarithm, just such that u is equal to what, u is equal to q1 r plus t1, and v is equal to q2 r plus t2. These, we have these things. Okay, now a की power m plus u is equal to a की power m plus v. Now put the values here, that is a की power m plus q1 r plus t1 is equal to a की power m plus q2 r plus t2. So a की power m plus q1 r is what? So what is a की power m plus q1 r? This is m, a की power m into a की power t1. This is a की power m into a की power t2. You can just write the logic in the bracket. That is a की power m is equal to a की power m plus q1 r, and also a की power m is equal to a की power m plus q2 r. Both are equal, so you just can replace by a की power m. So now what you have a की power m plus t1 is equal to a की power m plus t2, where t1 and t2 lies between 0 to r minus 1. So a की power m plus t1, a की power m plus t2, both are distinct powers, but distinct, if they are equal, it means again by previous case that m plus t1 is equal to m plus t2, so it implies that t1 is equal to t2. Now what you have, put t1 t2 same value here. So we have u is equal to q1 r plus t1, and v is equal to q2 r plus t1. Correct? Now you just can subtract both. So u minus v is equal to q1 minus q2 r. It means what? U minus v is a multiple of r. It means what? Again, u is congruent to v modulo r. So hence true. So it implies that u is congruent to v modulo r. So it means that in every case we have proved that u is congruent to v modulo r. So in this way, part B is proved. Now we move to part number C. What is part number C? Part C is that we have to prove that our claim is that monogenic subset group generated by an element A is equal to the element A square, or so on, a की power m, a की power m plus 1 dot so on, a की power m plus r minus 1. See, we have already seen that we have a की power m plus r equal to a की power r. It means what? That when we go ahead this power, it repeats, because what we have C, we have a is equal to what? This is more a square, a cube, or something like this. But what is the case? Case is that here, what is the case? That the repetition of powers do take place, isn't it? So for any s greater than equal to m, what we see, we have shown these things that a की power m plus r is equal to a की power r, and all powers of a in this set, that is a square, or so on, a की power m plus r minus 1, are distinct. This we know, correct? And powers are distinct because a की power m plus r is equal to a की power r. So for any s greater than m, apply division algorithm for integers s minus m and r. That is, there exist, you can say that there exist integers q greater than 0 and u which lies between r minus 1 to 0, such that s minus m is equal to what? S minus 1 is equal to qr plus u. Now a की power s is equal to what? A की power m plus qr plus u, and a की power m plus qr is what? What is a की power m plus qr? A की power m plus qr is what? A की power m. So it is a की power m into a की power u. That is a की power m plus u. Since a की power m is equal to a की power m plus qr. So a की power s is equal to a की power m plus u, and u lies between 0 to r minus 1. So where a की power s belongs? A की power s belongs to this set. A की power s belongs to this set, that is a square dot on a की power m plus r minus 1. So what we are seeing that when the power of a increases from m plus r minus 1, all powers belongs to this set and also equal to any one of these powers, because we have this relation a की power m plus r is equal to r. So actually, we get monogenic subsemigroup equal to what? This one, a square dot so on a की power m plus 1, a की power m plus r minus 1. So in this way C part is true. And from this I would also like to tell you that what is the definition of the order of an element A. Order of an element of A is defined as number of elements in the monogenic subsemigroup generated by an element A. Order of an element in a semigroup is defined as the number of elements in the monogenic subsemigroup generated by an element A. That is equal to this is equal to what? M plus r minus 1. So now what is order of A? What is M? Index of A. What is R? Period of A. So we can say that M plus R minus 1, that is index of A plus period of A minus 1. Now finally we will try to prove the fourth part. What is fourth part? B part, that is A is equal to a की power m plus 1 or so on a की power m plus r minus 1. We have to prove that this is cyclic subgroup of A. We have to prove that it is cyclic subgroup of A. It means that first thing, try to understand the problem. Subgroup, cyclic subgroup of A. It means that we have to prove that this set is a group. And also this set is a cyclic group. It means that we have to show that it is generated by an element. It has generator. Correct? and after that final and last we will also identify the identity of this group. Being a group, it must have identity, so we will also identify what is the identity of this. So this part is important in this theorem. So all of you can just image, just appreciate this, that this K is, this set is a semigroup. This set is a semigroup. See, KA is what? KA is what? It is a subset of this sub-semigroup. So being a subset of this, it will follow associate. Isn't it? Also, it is commutative operation. We follow both. Since therefore K is associative and commutative with respect to binary operation, with respect to same binary operation. Okay. Now, see, for semigroup we have to prove that it is closure. So also we have seen that for any s greater than equal to m, what we have seen, a की power s belongs to where? A की power s belongs to where? We have already seen that it goes in when we talk about this. We have already seen that when a की power, when we talk about a की power s. So it was just when we applied this is an logarithm, that is s minus m is equal to qr plus u, then it is what a की power s is equal to a की power m plus qr plus u. So it is what a की power m plus u. So a की power m plus u, it means where? It goes where? It goes in k. We have already seen for any s greater than equal to m, a की power x goes in ka. So K is closed, and hence K is what? Semigroup. Correct? So K is associative, and also we have seen that K is closed by applying Division logarithm. We have seen that for any s greater than equal to m, correct? Greater than equal to m. The element again goes in the same. It means that what if you multiply any two elements, the result will again go in K. It means that K is closed, correct? So K is what? Semigroup. Now, in order to prove semigroup, a group, what we have to prove? We have to prove existence of identity as well as existence of inverse, or we prove the equivalent conditions. Equivalent conditions means what? That if we prove that if G is for example, if S is a semigroup, and if we prove that for every A, B belongs to X, there exists X, Y belongs to S, such that AX is equal to B and YA is equal to B. If we prove this, it means what? These conditions are equivalent to the existence of identity as well as the existence of inverse. So if we prove this, we are done. So we will try to do the same. Now, for any a की power m plus q, a की power m plus b belongs to KA, correct? Choose X so that X is congruent to V minus U minus M modulo R. Now, calculate the value. a की power m plus u into a की power m plus x. Just calculate this. Now we have x power into v minus u minus m modulo r. It means what? It means that it implies what basically? It implies that x minus v plus u plus m is equal to what? You can say that qr. The multiple of r, x minus v plus u plus m is equal to qr. So you can put the value of x m plus x from here. You can just put the value a की power m plus u. So put the value of m plus x. M plus x value will be, that is v into a की power v minus u plus qr. So it will be what? A की power m plus u plus v minus u plus qr. It means what? A की power m plus qr into a की power v. It will be what? A की power m into a की power v. Since a की power m is equal to a की power m plus qr. Correct? So it is a की power m plus v. So see what we have proved. For any two elements of k, we got some element a की power m plus x, isn't it? Now of course a की power m plus x is from where? It is again from the k. It is again from the k. So we have seen that a की power m plus u, we are getting same equations. A की power m plus u is equal to a की power m plus x is equal to what? A की power m plus v. And of course, since this is commutative, so you can just a की power m plus x into a की power m plus u is equal to a की power m plus v. So both these properties use what? It uses that k is a group. Correct? K is a group. Now what is left more? We have to prove that k is a cyclic. K is cyclic, correct? Now before that, I would like to tell one fact that is the result of number theory. Integers 0, 1, 2, dots on r minus 1 forms a complete set of incongruent residues modulo r.